Alright, so hello everyone. I know it's been a while since I've talked to all of you about things related to programming. I think it's about time I actually pick it up again and just show you guys what's up. So what I have devised here is a little bit of a test, a little bit of a rant on why I actually do not like Rust, the programming language itself, why I don't like it, why I think it's pretty bad actually, and why there is no point in using it. From my personal experience and from other people's experience as well that I managed to gather. Also, I would like to answer with this method a few more things that I got from a few questions I got from my friends in regards to the projects I've been working on in the past little while. So what I have here prepared is, first off, before we get into comparing C and Rust, I know it's not fair, but it will make sense in the context on why I'm comparing C, a lower level language, than Rust, because Rust is actually being compared more and more with C++ instead of actual C. But one of my friends recently asked me, hey, you mentioned that you're working on this text editor, right? So why don't you use the Rust instead of C? Why are you going through the pain of writing it in C? To be frank, I started with this project about almost a year ago when I was trying to learn C. Is almost at the point I have released already another update, if you will, another alpha release. You can check that down in the description below, but basically it's a simple text editor inspired vaguely with Vim and Nano and combining them into one with basic syntax highlighting support as well. So you get that idea, hopefully. It's a bit clunky, it is a bit buggy, I am aware, but in my case it works, so let's see how this will go. Anyways, so I wanted to talk about Rust. So Rust itself, sure, it's a phenomenal language. Okay, cool. One really cool thing that I have to give them credit for is their documentation. They have a really large amount of documentation that anyone can go into, have a look at, test it out, see what it's all about, and see what's up with the language, which I really do like. The documentation is amazing. It's really cool. You can look up basically anything that you wish, and you can get basic programs running. They also explain the anatomy of the Rust program. So if you are looking for a pretty beginner friendly, it is kind of beginner friendly, but it's really user friendly. It's a really user friendly language. So if you're looking for something to get your back into and try out something new, and you do not care about performance or waiting around for stuff to happen, go with Rust. However, if you're obsessed with performance and are looking to get the best in terms of your computer's performance, this is where C comes in. So, to show you something, I have prepared here a bit of a test, a really simple test. It's really simple. Basically, this will be a compilation test and then an execution test to show you that Rust is actually pretty bad when it comes to compiling, and sometimes even execution takes a long time. But to give it the best chance possible to get this running, I've devised a really simple test. So the test is real simple. We have two source files. Both opened in my text editor called Tin that I've been working on for the past little while, and it has basic syntax highlighting support. But basically, we have here our Rust program over here, and whoops, that's not what I meant. For some reason, it didn't work as I wanted it to. There we go. So we're in the editor now, over there. So this is basically the simple program over there. Really simple, real simple program. A simple hello world program, the one that everyone should start out with. And the same goes for C over here. Same thing, we do have the exact same thing pretty much. But is it really the thing that we are looking for? So let me just save over those files. Immediately a difference that you can see, it's in the source files. It's a few bytes, so it doesn't really matter. The real killer will be during the compilation. So to show you that it actually takes astronomical amounts of time to compile Rust code. Actually, hold on, let me clear this out so we are fair with it. Where's the command? There it is. So to make this as fair as possible, we're going to use both optimizations for O, which is for optimizing it, and we're going to use the same level of optimizations, the exact same levels. We will try the same thing without the optimization levels, so that it is as fair as possible. So in case someone didn't like my methodology of using optimization flags, we can do it without. The reason why there is the time command, it's a Unix command that you can use for measuring time. To show you this, if we open up the man page for time, let's pick the first one. It basically is a simple command to give you resource usage and for how long each resource has been used. It gives you how much real time it took, how much CPU time, user, and stuff like that. You can pretty much play around with this as much as you want. You can also get memory information, but we're not looking into that right now. We're going to look for file sizes, which thanks to the help of our ls-all command here, we're going to get a really down to the byte size about the information of each file. As you can see, the C level code is 127 bytes, and over here it's the Rust code is 149 bytes. Now bear in mind this one has a lot more going on in here, so that's why it's larger. So I wouldn't take the source code as a valid point of comparison, because it's going to do the exact same thing, and also to just show you something to make sure that everyone is like happy with this, we're going to remove all the comments, so pretty much all the unnecessary stuff from the files themselves. So already in our C code we're down to 75 bytes written on our disk, so already half of the source code file has been gotten away. It's as simple as that. And we're down to 44 bytes, so technically Rust's code is smaller now than in C. So that would be a win for Rust in terms of source code, right? It's much smaller, it's much more compact than it was before. Well, I wouldn't take this as a valid point of comparison just yet. Don't celebrate just yet, guys. It will get really, really ugly real soon. So I mentioned these optimization flags right here, right? Let's compile it. Let's see how long it takes to compile in C first. And boom, there it is. It's done. Took almost no time at all. As you can see, almost no time at all with O fast, which is pretty much the exact same level of optimization as over here. Took pretty much no time at all. And almost no CPU usage involved. Let's run pretty much the same test over here. That's not good, that's actually quite high. How much is that? Well, let's bring out the calculator. Let's do some calculations real quick. So let's do 0.382 and divide it by 0.74. My bad, I did that really wrong. There was a 0 in there as well. 0.382 divided by 0.074. We're taking the total time it took. We're not looking anywhere else. We're looking only in the total time it took to execute the compilation. It's about 5 times faster. 5 times faster for C to get compiled. Alright, so what else is there? What else can we do to actually prove that Rust's compilation time? So we already proved that Rust's compilation time is pretty bad. But what about the file size? How big are the files? Well, this gets real interesting. If we open this up and we run the ls-all command, remember these are in bytes. So we're looking at around 24 kilobytes for our C code to get compiled. So test.c is our C code, and that's 24 kilobytes, so around 25 kilobytes in size. That's pretty reasonable. That's pretty good itself. That's not good. That's 326 wait, that's actually more. That's like 3 megs. That's 3 megabytes, or no. That's not good. We can actually use the human flag to better visualize this. So the test here is this one. That's for our Rust code. It is pretty large. It's around 3.2 megs in size, whereas our test C file, which is over here being generated by GCC, which took even less time to compile, is around 25 kilobytes. So it's much larger, like orders of magnitude larger. We can actually do some calculations on this as well. So let's take this number right here. We're going to copy this. We're going to clear this out. We're going to divide this by this amount, see how many times we could fit our test.c file, the exact same program, mind you, but written in a different language. So let's take that and let's see how many times we could fit it. 132 times on average. We could fit our program 132 times in that. That's not a good showing, is it? So not only are C programs much smaller, but they also are much faster for compilation. Now, bear in mind, it isn't that long of a time. That's actually still reasonable, but it did take some time to compile. But that was only compilation. Imagine having and that was only with one line of code technically for Rust. So Rust should have the advantage of a smaller file size, but yet it doesn't. So even using optimization flags doesn't work for Rust. It's still losing in that department. Same goes for file size. But maybe execution time might be on its side, isn't it? Well, let's see if it is true. We did compile a test file. So remember that file I showed you before, the test file? This is the file we want to execute. That's a binary file. That's 3.2 megs. Alright, that's pretty good. That's pretty decent. Didn't take almost any time at all. What about test.c? Whoops. So we type in time test c // test c, and let's see what that does. And 0.02. So technically it took less time to execute than before. Pretty much half the time. You can see it over here. 0.04, 0.02. It took half the time to get executed. Now, that's all cool and dandy, but this proves my point. I won't be using Rust because of these things. Sure, it has some really neat features, but you might argue, wait, but Rust has a safe and unsafe mode and stuff like that. We can make it faster. Okay, but can you make it fit in there? Yeah, you could try, but unless you reduce the code or functionality of your code or your program, I don't think you're going to be able to really stand up to much better languages like C. And that's effectively one of the major reasons why I won't be using C as a programming language. I won't be using Rust, so Rust as a programming language for any of my projects. I do have the compiler and everything installed for those who need it. I'll be making a video on how you can install all the compilers and everything under OpenSUSE. But as of now, I don't really see the point in using Rust. Sure, the code might be smaller and easier to read. Okay, that's cool, but is it really a valid point, being user-friendly at the cost of space and time itself? I don't think it is worth it. I really don't. So anyways, I think that's pretty much enough for now. And I thank all of you for joining me today. Make sure to leave a like, subscribe, and I hope to see all of you beautiful people next time. And also make sure to leave your thoughts and ideas for other future videos or projects down below if you want to compare even more languages just like this. So yeah, that was my small rant on Rust. Hope to see you all next time. Bye bye.